All right, so now we know how to, from the last video, uh, draw the Lewis structures of different atoms or elements, right? And so now we're gonna get into drawing Lewis structures of compounds eventually. But before we do that, we have to talk about what different types of compounds there are. And so we can classify all of matter. We did this during one of the earlier chapters. Into mixtures and pure substances. Here I'm just looking at pure substances. We know that mixtures are just combinations of pure substances. So pure substances, right, can be elements, which can be atomic or molecular, or they can be compounds, and those can be molecular or ionic, right? Molecular were discrete species, right? Exist as discrete species. And where you're sharing electrons, generally covalent electrons, and ionic were more these extended solids where you have pluses and minuses all aggregated together in like something like a sodium chloride crystal. Okay, so ionic versus covalent. Again, covalent is going to be sharing of electrons. It could be, a diatomic element, that would be a covalent element. Or covalent compounds, but they're discrete, they're molecularly discrete, versus an ionic compound where it's an extended solid. And you have these repeating units of plus and minus ions. Ionic compounds, remember, are formed from a metal and a non-metal. We talked about that when we went over our naming rules. Covalent compounds are when you have a non-metal and a non-metal, okay? And soon we're going to be able to see why with some of the principles that we've built up. So how would we draw this out? If we had a ionic compound, well, that's going to mean we have something like sodium chloride, where we have a sodium cation and a chlorine anion. And we know that ionic compounds, there's a transfer of electrons to form ions from the neutral elements. And so you could start off drawing the Lewis dot structure for a sodium atom, which would look like this, and a chlorine atom, which would look like this, right? 7 valence electrons, 1 valence electrons. And what's going to happen? That electron, that valence electron from the sodium, is going to get removed and transferred and complete this octet, these 8 electrons, for the chlorine. So that's going to make a positively charged sodium because we lost an electron, and now a happy negatively charged chlorine with 8 electrons. So sodium's happy because it doesn't have any valence electrons. It's like the previous noble gas, like neon. And chlorine's happy. It's like argon because it now has a completed octet. So it has the same electron configuration as argon. You could also do this with a covalent bond. Okay, now it's sharing. So that would be something like chlorine and chlorine, non-metal plus a non-metal, right? And so both of these would have 7 valence electrons. They come together and they're going to share and make a bond between these 2 electrons. They're going to share those so that each one then feels like they have 8. So each one effectively has an electron configuration of argon, like a noble gas, and they're both stable that way. Okay, so this is what dictates bonding, guys. Bonds are going to form to 99% of the time, and all the stuff that we're going to talk about in this class are going to form to have noble gas type configurations. And that's going to tell you whether or not you're going to have an ionic bond or a covalent bond. Are you going to do sharing or are you going to do electron transfer? And so here's another way of looking at this is, this is kind of a spectrum between transferred and shared. You can share equally, like if you have 2 chlorines, both of those chlorines are going to be vying over those 2 electrons equally. Another way of saying that is the electronegativity of both chlorines is equal, right? They're the same atom. Or you could have what's called a polar covalent. So that'd be a non-polar covalent bond. There's no polarity. There's no negative or positive charge there. It's all equal sharing, equal tug of war. There's a tug of war, but they're pulling equally as strong, okay? You can have what's called a polar covalent bond where you have, let's say, fluorine and chlorine. Fluorine, right, is the most electronegative element. So fluorine's going to win out over chlorine. And so the electrons are going to go towards fluorine more so than chlorine. So you're going to have a slightly negative charge on fluorine, a slight positive charge on chlorine, okay? But they're still sharing those two electrons. The extreme case is where the electronegativity is so great, like between a metal and a non-metal. If you look up the electronegativities of these are very great. And we'll get into this later about the difference in electronegativity, where you have an ionic bond. And now you did the tug of war, you set up the tug of war, but chlorine just ripped off an electron from sodium, and now you have ions. You have ion transfer. I was going to in class show this really cute video of dogs, okay? So if you type in like bonding chemistry dogs in YouTube, you'll get this. I'm not sure if within a YouTube video I can show a YouTube video, so I didn't want to do that. But bonding chemistry dogs, it'll get you there, and it's just kind of fun. Okay, it goes over this. They're gonna pull the toys from each other, representing electrons. Okay, so I think we can stop there for this video, and we'll continue talking about how actually a covalent bond forms in the next video.